Right, today's lesson is on lesson 1-3. It's describing the transformations of graphs. So again, we already went through all this in class, but I will try and go over it again with some clarity so you have access to it beyond just the day we did it in class. So what we're talking about first is the general transformation equation with our A, our H, our B, and our K. And the first thing we did actually was define those constants. So what we said A was our vertical stretch. So anytime you have a number out front, what that's doing is a vertical stretch of our graph. Now, when we use the number A, that's in the equation, but how does that affect the graph? We say that it stretches the graph vertically by a factor of, and in this case, it's not just a factor of A, but the absolute value of A. So if A happens to be negative, the vertical stretching alone is just the positive, the absolute value of. If it happens to be negative, what we said in class is if that's negative, what that does is that takes our graph and it reflects it across the x-axis. And I ran out of room, but again, I think hopefully you remember that. And the idea was, yes, that the negative does affect the graph by flipping it across the x-axis. Our H is our horizontal translation. Now, in class, what we said was a translation is just the technical term for a slide or a move sideways. So you could just say horizontal shift, that was fine too. But what we noted was that if H is greater than 0, then that actually shifts the graph to the right. And if H is less than 0, whoop, I said less than or equal to, that is not right. If it's less than 0, then we go to the left. So that part does get confusing to some people because our formula says x minus h. So a lot of people say, oh, x minus h, so x minus 2. Well, it's minus 2, so we shift to the right. It's negative 2 to the right. The problem, the clarification I want to make is that the standard form is a negative h or minus h. So if we were to say x minus 2 and we isolate the h itself is positive 2. So our formula, x minus h, you think, oh, minus 2 to the right 2, but this is different. We're looking at just the variable h, and in that case it's 2, and so we follow this rule. H is greater than 0, h is 2, so it shifts it to the right. So that kind of, it can be a little bit counterintuitive in that way. B, we have our horizontal stretch. And this one also, so we say it's a horizontal stretch by a factor of, and just like the vertical stretch, we don't just take the B value at face value. So if B is 2 in the equation that we're given, horizontal stretch is by a factor of 1 over the absolute value of B. Okay, that's another tricky one. Meaning that if we have a whole number here, so B is 1, or well, 2, 3, 4, our horizontal stretch really becomes more of, some people will call it a horizontal compression. because your factor, by a factor in that case, would be half, so 1 over 2. So if b is 2, we stretch it by a factor of 1/2. In class, what I said was some people may refer to a fraction, a stretch by a factor of a fraction, as a compression, and that's fine. It's perfectly acceptable. But for my purposes and for clarity, I will never change using the word stretch. So I will always call it a stretch. Some people would call like shrinking a compression. So in that case, yes, it's positive. It is by a factor of 1/2 if that b is a 2. Now, what we have to also account for is the fact that if b happens to be negative, so -2 does have an effect on the graph. If it's negative, we then reflect across the y. Whoop, got ahead of myself. All right, so we got those 3 taken care of. And our last one, most people find pretty simple, but our k value at the end is our vertical translation or vertical shift. Nothing much to it other than a shift up is positive, down is negative, so that's pretty intuitive that way. Let's see. So now we want to talk about the order of the transformations. So if we start with point P at -4, -2, we're going to look at translating this or transforming this in 2 steps. So step 1, so part A, we're looking at part A here. If we compress it horizontally by a factor of 1/2, that means that instead of going from 0 to -4, okay, there we go. If we go from 0 to -4, we're actually compressing that in half. So rather than going all the way to -4, we just go to -2. Now that compression does not affect our y value, so we just leave that. Then shift it left 3 units. So now we've gone from -4, cut it in half to -2. Our -2 gets shifted left by 3, so our ending point is -5, -2. The question at hand is, does the order matter? So step B, or part B says, let's switch the order. Let's shift left first, then compress horizontally. So we're going to shift left 3 first. So we're going to start at -4, shift left 3, so we got -7, -2. So step 1, shift left. Now let's compress by a factor of 1/2. So now instead of going clear out to -7, we got to take that in half. So -3.5, -2, and part C says, is the order important? Yes. So if you notice, we went order A, and we got point -5, -2, and then we did the order for B, same operations, same transformations, we just changed the order. And as you can see, it absolutely mattered because we ended at a very different point. So if you're looking at the bottom of the screen, now more the middle here, this is the order of operations for transformation. So just like we have an order of operations in algebra, where we take our parentheses, our exponents, then we multiply, divide, and add, subtract. Here we take our first step is all of our horizontal translations, then any stretching or shrinking, then any reflecting, and then finally our vertical translation. So we start with the horizontal shifting and we end with vertical shifting. Well, let's keep going. See if I can't get a couple examples. So I'll do examples A and B at least. So here we have 2 f of x minus 8 plus 4, and it just says simply describe the following. You know what, I'm going to stop this video just so that I can chunk it out. We're right at 10 minutes here. So I'll stop this and I'll continue the examples on a separate